Hello, Professor. Today I will walk you through our suicide rate forecasting project. We build a machine learning pipeline that predicts suicide rate using public health data. The goal of the project is to help health officials to identify high risk groups and plan better interventions. So what we did differently, we combined three entirely different health related data set, which include chronic disease indicator, suicide death rate, with the demographic prevalence and drug overdose death data set. So our first step, what we do is we loaded the data. If I show you here, we are loading our data set accordingly, and step step two, we started cleaning the data by copying the data frame, and we started year filtering where three data sets doesn't have the same time window. So we use a programmatical method to figure out the time window which overlaps on each data set, and we started cleaning the data for outliers. For example, uh, uh, all three data set have different year ranges. So we picked years where all had the data. We removed bad data like negative suicide values, which obviously make no sense. And for missing values, instead of deleting the entire row, we used median values. So by following these kind of steps, we can able to retain most of the valuable information in this. So this is our data cleaning setup. And step four, what we done was creating a better features for our ML models. So this is where we get creative. Uh, we introduced different advanced features like lag features, which says last year suicide rate for each group, because past rates helps in predicting the future rates. So we used different lag features. We introduced different language lag features, and we also introduced population average feature, chronic disease indicator features like rate of diabetes, heart disease, and etc. And the demographic codes like uh, converted text categories to numeric for machine learning models to train. So why this matter? Instead of just using raw data, we created new features that capture patterns. For example, if demographic groups have high suicide rates last year, then they are more likely to have high rates in this year too. So these are the advanced feature we introduced into our data sets by assessing the data, previous data set. And uh, what we have done this here was combining all those data sets. So the how we merged everything by was like we used left join method to preserve suicide data. Like, so we you can clearly see how we used left join to enhance data set in data set richness. So each data set organized data differently. We had to carefully match them by year and demographic group. So this was the challenge we faced. And our solution, we used a step-by-step matching approach, keeps all the suicide data and adding other information where available by embracing the left join method. So next, what we have done was preparing the feature set for ML model. So we handpicked few feature sets as a target variables, as relevant to our target variable. So important decision we made was time-based split. We trained on older years and tested them on recent years. Not it's not a random split. Feature selection, we only kept features that had good data and various across observation. And why time-based split? If we ask why it's time-based split, in real life we use past data to predict the future. So random splitting would cheat by using future data to predict the past. So finally, my model, it's random forest model. So uh, random forest model was trained using 200 different decision trees. Each tree makes a prediction. The final prediction is the average of all trees. This makes it more accurate and less likely to overfit. So on our results, the results it's produced is like MAE score, mean absolute error, like 0.97. On average, we are off by 0.97 suicide rate points. The coefficient where it's 0.97, we explain 97% of variation in the suicide rate, and the root mean square error. The root mean square error shows the good prediction, and the accuracy. The accuracy. So the accuracy very good at categorizing the risk levels. So what features most matter is last year suicide rate of the same group, mental health indicators, and the age group and demographic categories. And finally, the chronic rates are also influence the suicide rate prediction. So finally, we created a cell which compare each model. So this is the last cell which compares all trained models. So in our comparison, the accuracy, if we take the point of accuracy, the random forest outperformed other two models. Where if we take elastic net as an example, the elastic net performed very well in the case of speed, latency, and throughput. So and the neural network, it needs more data to be trained, because the merged data set results in around 1,500 entries, which is okay, the okay level of data set, where neural network requires more intensive data and different data to train well. So the surprisingly the best performance model would be like elastic net, which fits best to overall choice, because it finds the sweet spot between the accuracy and the speed, while random forest is more accurate, and elastic net is good enough for the most of the application, and its own way it's way faster. So the main work the main work which makes our process different to different extent is combining three different data types. So nobody for our knowledge, there is nobody else has systematically combined suicide, overdose, and chronic disease data for prediction. Demographic time series. So we track patterns and correlation over the time for a specific demographic group, not just only for trends. So real world ready. Our pipeline is fast enough and accurate enough to actually use in health department. So it helps health officials to identify which groups need most help, better planning for mental health resource, and early warning when suicide rates might be increasing. So that's our project.